So the whole time I'm doing the video, this is what my screen does. You can see me in the background because it's like a mirror image. So just so you know why I'm acting like an idiot during the video, this is how my screen looks when I do it. Okay, I think it's going to work. We'll see if it holds. We're live, 2018. Of course, when I use this video 5 years from now, then it's going to be old because I usually keep the movies up there forever. But anyway, right? Haven't you been watching 2013 videos? Ah, all right. It's because this computer is a little touchy about doing videos, so we'll see what happens here. Hey, class. Today we're going to be doing piecewise functions. That's functions that is defined by pieces. Doesn't that sound reasonable? Nah? And then for the last hour class, I'm going to leave this up here. Good. I just cut that off so you can't write that. All right? Oh, there is a little delay. That makes me nervous. Did you finish? Oh, yeah. And that was actually open notes, too. Is you sure? Okay. Oh, you done? Okay. All right. I put this little thing over here. You don't have to write it, but I talked to my students last hour about where in the real world would there be a piecewise function. And I gave them an example of ancient times, well before you were born. We had cell phones in the 90s, but you won't believe it. All they could do was make a phone call, and that's it. They could do nothing else. All right. And back in the day, I literally did have a $200 plus phone bill once because I was using it as my primary line. That particular month, I had a lot of things going on. You didn't even get to track your bills online at that point. So basically, you got a piece of paper the next month with your phone bill. And I wasn't ready for this. My particular package had a limit on minutes for a monthly charge. So I just made this up last hour. I was charged potentially, let's say, $30 a month, and that gave me 100 minutes of phone calls. After those 100 minutes, though, then the company started charging you per minute. That is the truth. Now, I know some of you guys have limited data packages. Similar scenario when you have limited data packages for all the things that your phone does. So this is a piecewise function because it's defined in different intervals, different pieces. If I call and I use 30 minutes of time per month, I would still be charged $30. If I called 60 minutes, I still would be charged $30. If I did 100 minutes, $30, a constant charge. After that, the company got you. And it was as ridiculous as close to $1 a minute for every extra minute that you called. That's why my phone bill was well over $200 one time. And I was not happy about it, and I didn't really realize it was that bad and didn't realize I was doing all these phone calls. Here's another thing they did. Do you know if you called 2 minutes and 1 second, do you know what they would charge you for? 2 minutes or 3 minutes, what do you think? They would go to 3 minutes. Anything over that. Yeah, they were little sticklers back in the day. So the next piece of this function is from 100 to 101 minutes, I was charged $31. All right, notice the jump off. At 100 minutes, I was charged $30. That's why this is a closed dot. Why do I need an open dot here? It's just the next step. You're not charged $31 at 100 minutes. But 100 minutes and 1 second to 101 minutes, you are charged $31, and so on and so on and so forth. So I hope you get the idea of what a piecewise function is. The second thing is, here is a particular piecewise function that I made a decision last hour to actually do one of the things that you might have to do. And that is come up with the equation from this graph, and it should not be hard. Okay, class, let's pretend that you're here. Oh, I did third hour. They don't answer my questions ever. This is going to be awkward in the movie because it sounds like there's no students here. Hey, class, what is this? A picture of a what? Did you hear them? And then what's this a picture of, everybody? Can't you get an equation of a line quite easily? So let's go ahead and define this piecewise function by one function name. And this is how the format of it looks. You put a brace. This f of x is defined by two different pieces, just like my phone bill is defined by a whole bunch of different pieces depending on how many minutes I would use. All right? Let's go back to this. All right, and again, for second hour, I bounced around the groups and made them answer these questions. Because I decided to tape you, I'm just going to go with the standard lecture here. But I will see if we get group responses. The first line, I'll write in red the equation. What is the y-intercept of that first line? Class? It's -1. What is the slope of that first line now that we're looking in the right spot? Hold on, we got to pause. Well, what did I do? I hit the wrong button. Hold on, sir. You're making me panic. Oh, my God. All right. What's the slope of that line? Good. Rise over run. And this is what I mean about knowing your stuff. This is 2/3 x minus 1. Knowing what the equation of a line is, we're not going to do lines by those transformations, so I'll just leave it at that. And then let's do the other line in, let's say, blue, just because it's a little different. What's the y-intercept of that line right there, that piece? 3. So it's +3. And then what's the slope? It looks like negative what? -1. Okay, so it'd be -1x plus 3. Notice I didn't put y equals in front of those because f of x equals then these two pieces listed. But that's not enough. Not at all. And this is what I'm hammering the point for on this little worksheet that I pulled off and stole from the internet because it's awesome. Those are just two random lines. How do I know where to stop one and begin the other one? Well, that is this part. You write conditions after that, and the reason I'm doing this is now you understand what piecewise functions are and how they are defined. What did I graph this red line up to? Where did I stop it for x? Where did I stop it for x? I stopped it at 0. Is 0, 0 a coordinate for that line? Yes or no? No, that's an open dot. So now what we have to do, and this is why I've been training you on Algebra 2, even though we do interval notation. This is the conditions that I can graph this line in. And that's what we need to understand when we see a piecewise function. I get students ignoring that all the time. They don't even look at it. They just think it's there. I don't know. And then what is the second function defined by? It starts at what? For x. And goes off to what? What do I plug in for x after that? That arrow means what? Infinity. So if I were going to do this in interval notation, you'd say 0 with a bracket to infinity is what the x values are that I'm plugging in. Here it goes. Look at. Okay, I'm going to stop. I got to record this. Okay, we'll see. Do you see it? Okay. So this is what I deal with. When I'm doing this video, this is what I see. And then I end up getting like convulsions, and I end up having a, what is that? Oh, and you can see me like in the background. So, I just got a student in the video. I can't do that. Shoot. Look at this. I can't do videos this year. But you know what? I'm going to persevere. Because you know why? Somebody say it. Never give in. So I'm going to do the rest of these notes and have a seizure because I have to look at this. But it's not going up there, is it? It's not going up there. Okay, so here we go. We're going to keep going. All right, so what's the conditions as I see this flashing screen? Look at what's happening. Okay. Oh, and I get the pen there. Sometimes it stops. This is for all x's greater than or equal to 0. You cannot ignore these conditions, all kidding aside. I'll try to keep the pen there without, having this flash in my face. But again, online you don't see that that's happening, but it is. It is. It is. Okay, so here we go. Let's try to slide down and look at this. Your homework is, your first 2 pages are going to be real easy because of these questions. And I don't get the answers. You got to really focus here. Plus, I'm dealing with this computer. What this means for this particular piecewise function. These are how things are defined. So this chunk is defined by these x's. This chunk is, oops, that's a mistake. That's my fault. This chunk is defined by this interval that I can plug in x's, and so on and so on and so forth. So you should get that. So where should I plug this negative 4 in for x? And by the way, what does f of negative 4 mean? It means negative 4 is x, and I want to find the y, or the output value. So which one do I plug that in? First, second, or third, according to the conditions? Which part of the piece? First. Negative 4 is less than negative 2. So therefore, I must plug that into the yellow. 2 times negative 4. I'm battling the computer. That's why I'm writing kind of, this is pretty tough. If anyone looks at my computer, you can see it's still flashing. Black, white, black, white. All right, and then what do I do for f of 6? Which part of these? The yellow, the blue, or the unhighlighted? Which one can I plug that into? First, second, or third, guys? Oh, we're not getting it. Someone said first, and the rest isn't saying anything. What is 6? Is it between negative 2 and 3? Is it less than negative 2, or is it greater than 3? It's greater than 3, so I should plug it in this piece. That's why I love this thing that I stole from the internet. It really exercises the point of the pieces and how they're defined. All right, and then once we get through this, then you'll be able to do graphing of these. Where should I plug this one in? F of negative 2. Now, this is a tough one. Where does negative 2 fall in the interval? Is it the yellow or is it the blue? It's actually the yellow. All right, and when we go to graph that, we'll see what we have to do. We have to plug that into the yellow piece because that's where this function is defined when x is less than or equal to negative 2. Love it. Whoever made this, it was free on Google, so hopefully I didn't steal it, blah, blah, blah. Where should I plug in f of 0 then? Well, where is 0? Yellow, blue, or not colored? Third hour, you make me so sad. Which one is it? First, second, or third? It's the blue, the third. So it's 0 squared minus 3, which is negative 3. There are students in here, believe me. All right, so we'll press pause to take a break from the flashing screen so I don't go crazy. I skipped around. We're not writing these down, but we're verbalizing them. There we go. Flash, flash, flash. What would f of 4 actually be? I'm not looking at it. What would f of 4 actually be? 3. Do you know what this is a picture of in this little piece? Oh. A horizontal line. Okay? So f of 4 equals 3. All right? And then what would I plug f of 5 in? Where would that be? Second or third? Third. F of 5. 5 defines the next function. 5 minus 2, then absolute value. All right? We're going to try to proceed on. Okay, flashing screen, you all see it. And then here we got this. All right? And I don't know if you'll be able to take these down as notes. You're going to have to really quickly scratch it. Maybe we'll just do one, and I'll move in on this graph. Go ahead and take that down for a second, and I'll come back. I'll take a break from the flashing screen. This is just it, but try not to mention it anymore about the flashing screen. There it goes. Okay, so what's f of 2? Hey, inputs, what? Output, third hour. Okay, x, comma, what is f of 2? What's 2, x or y? 2 is x, and what is it looking for? The y value when I plug in 2. And according to this graph, when I plug in 2, what do I get for an output value? Negative 1. So again, a piecewise function, analyze the pieces and know what parts we're looking at. F of negative 3, now that's a good one. F of negative 3, is it 1 or is it 2.5? What's the right answer according to these dots? And the answer is 2.5 because this is the step off from this piece to this piece, and that's an open dot. So no, it's not 1. That's just the start of that horizontal line and moving on. Okay? And then what's f of negative 1? Well, look at this graph. This is weird. F of negative 1, what kind of dot is that? And what kind of dot is that for both of those pieces? We got a little delay here. Open. So what's f of 1 then? What do you think you'd have to say? What do you think you'd have to say? Doesn't exist. It's undefined at -1 for some weird reason. You don't have to analyze it any further, but there's no -1 comma that exists. Those are two open dots. So that exercises the idea that we have open dots there, and -1 is not defined at that particular spot. All right, we got a question. And then, of course, what's f of -4? Well, we got another... No, we don't have another step off. What's f of -4? Oh, third hour. Okay, it's coming. It's coming. Maybe it is. There it is. What's f of -4? 2. And I don't think I have to do another one. Okay, same idea. By the way, what does this look like a picture of right here? This is what, understanding. What does that look like a picture of, possibly? Which of your 6 functions I told you you're supposed to memorize? Square roots. Okay, and that's another thing that I don't think we're really good at right now. Understanding, you know, exactly when I'm looking at a picture, which of my... I know I said 12 family of functions, but knowing which one's which. Okay, now it comes to the actual graphing of this. All right, I got to be able to ask, you know, second hour, a lot of questions. Again, we're just going to go through this, and, you know, you got to be able to handle it. Okay, trying to get a video, a new one, for the people in 2018. So what we got to do is graph this piece. By the way, what kind of line is... I don't know where to put this. Y equals 5. Don't say red. Don't say straight. What kind of line is y equals 5? Horizontal. If you don't know that, that's a problem. The next thing is where can I graph this horizontal line? All right, and that's when I focus on that interval, I guess I could call it, our restriction. All right, and the answer to that is I can start it at 2 for x, comma 5, and I put a dot there, and then which way do I draw this graph? You draw it left, and that's the piece. What I get ridiculously is people draw this full horizontal line all the way across, totally ignoring these conditions, these limitations on the pieces. And then they do the same thing for the next chunk, and we have two graphs running into each other, not analyzing that whatsoever. So again, all I'm trying to do is teach through common errors as well. All right, and then I'll go green. The next piece I need to graph is y equals 2x minus 4, which again is a linear line. Interesting. That's like saying straight line. I like it. Redundancies. What's the y-intercept of that line? I'm going to throw a desk for how many people don't answer that question. What's the y-intercept? -4. There are some people. What's the slope of this line? Do I graph the y-intercept? Am I allowed to graph the y-intercept? Yes or no, according to these conditions? No. So here's what I'm going to tell you to do on piecewise functions. You should create a chart just like you were supposed to do the last 2 worksheets. You were supposed to do it by hand and graph by knowing what your transformations were and then getting some specific dots, or else you're doomed in my class. Done. So what should I actually plug in? Should I plug in 2 for x technically? Yes or no? Should I? According to these conditions, should I? No. So here's what I get students do all the time. They say, oh, I can't plug in 2, I'll plug in 3. And I'll show you a common error here. By the way, what happens when I plug in 3? What do I get as an output value? 2. And if you can't do that, there's a problem. 3 times 2 is 6. 6 minus 4 is 2. So 3 comma 2, this is what they do. 3 comma 2, and they put this dot, and then maybe one more. Or you can use slope at this point. Rise 2, run 1. You get some sort of picture like this. And then this is what you miss when you do this. You're missing a whole infinite amount of coordinates between those 2 graphs right there. Wow, is this really behind? I can see why maybe you're not answering some of my questions. We got a wireless situation here. So do I plug in 2? We actually do plug in 2. What do you get when you plug in 2? You get what? 0. I want that still green, but I won't change that color. But what do I put at 2 comma 0? An open dot. And I wanted to actually make that a different color to really demonstrate a common error that students make. They miss that blue graph right there. I'm sorry, green and blue are very close to each other. Common error is they literally read that x is greater than 2, ignore decimals, and go to 3 in the chart, graph 3 comma, and then 4 comma, and don't do that little blue part. You are missing all of these coordinates then, and that will be marked wrong, just so you know. All right, so now we're going to go to our complicated questions. This is actually part of the homework, and I'm going to tell you right now you should have no problem with it. All right, this is going to take like 5 seconds per question. All this is an exercise of which piece do I go to plug these numbers in. All right, there you go. And then the same thing. Which part of the graph represents these f ofs? I just went through that with you. Those should be 5-second questions. Same again. And then I'll tell you when we get to this page, we won't do 9 and 11. So I'll tell you that in class. Then the second part is some more complicated piecewise like this. So go ahead and take a moment to take this one down. All right. And because of time, because I'm doing a video, it's hard to stop and ask students stuff. Plus, you'll get done faster in the other class. But here are the function definitions, but I don't want to do that. What I want to do is I'll take each one in colors. Here are the conditions that you graph these under. All right, and that's what we use that internet sheet that I stole to control where you're going. So the first piece I'm going to graph in yellow. And I'm going to pull it out and just say y equals 1. What kind of line is that yet again? Horizontal. And if I were to make a chart, like I said, for students that struggle with this in the past, you should make a chart. And actually, I'm going to do that even with a horizontal line. What can I plug into this horizontal line according to the conditions? Can I plug in -2? Absolutely. And what do I get when I plug in -2? It's a horizontal line, so you're always going to get what? No, what y value? 1. And then what should I plug in next? -3 and get 1. And that's good enough. What this says is this piece starts at -2 comma 1. What kind of dot? Opened or closed? Closed because of the equal to in the condition. And then I didn't even need the second one. It's a horizontal line going left, and it stops at -2 with a closed dot. I almost said open. Then you proceed on to the next piece. I'll do that in blue. Y equals 2 plus x. What is that again a picture of? What is that a picture of? A line. Right, MM? So you're looking out the window. Isn't it a nice day? Yes, Mr. Samuelis. What should I plug in for x in this one? What should I plug in? Look at the condition. Should I plug in -2? Yes or no? Actually, yes. But what do I put for -2 comma? What's -2 comma, by the way? What's -2 plus 2 or 2 plus -2? So at -2 comma 0, I put an open dot because I don't want to ignore what happens between -2 and -1. By the way, a line, all you need is 2 points to graph it, correct? So what should I plug in next in my chart? Look at the conditions. Don't say -1. Don't say 0. What should I plug in next? I should plug in 3. It's a 3. That's a equal to, less than or equal to. What do I get when I plug in 3? I think we have some problems. Some people can't do these simple calculations. It's the only explanation for when I take your calculator away and tell you to graph something, you can't graph it. Look at how shaky I am. I had a rough day already. All right, math meetings in the morning. Oh, they're so great, let me tell you. All right, and then green. I should pick something different than green. Let's go orange. Y equals 2x. What should I plug in for y equals 2x? Should I plug in 0? Yikes. No, should I plug in 3? Yeah. Yes. And then what do I get when I plug in 3? What kind of dot should I put for 3 comma 6? Open. Sorry, I picked a thick pen. And this is going to kind of look bad with my limited coordinate plane. And then I could do one of two things. I could use slope, rise 2, run 1, and then continue the line because it does go forever after that. All right, so I hammer down the point. The common error that students do, they ignore that these even exist. And then I end up getting these ridiculous graphs of students doing this. Okay, y equals 1. Whee! Y equals 2 plus x, whee! And then y equals 2x, whee! Oh, whee! Oh, that was supposed to be orange. Whee! Okay, that's enough. And then I just get 3 pictures. Man, she hates this class. 3 pictures. 3 pictures is going right through each other because you ignore the conditions. Anyone? Acceptable. Who said acceptable over there? Nice. That's what I was looking for. All right. Take a minute to take this last one, and then this is the last time you have to hear my voice. Thank the maker, if there is one in a public school. Here we go. Just so you know, it's still happening. See it? Fun. Alrighty. So fighting through it. Y equals. What's this a picture of? 2x minus 1. What's that a picture of? A linear line, he said again. What can I plug in for that? What from the conditions, what am I allowed to plug in? Should I plug in negative 2? What should I make that dot when I plug in negative 2? I'm not even asking. If you don't know how to evaluate this and get negative 5, troubles. Negative 2, comma 1, 2, 3, 4, 5. And it's an open dot because I'm not really supposed to plug in negative 2. And if you don't get that, I don't know what's going on. Blah. And then I could either use slope but go backwards down to left 1, or I could plug in negative 3 and get that negative 7, which is actually true. And then it goes forever this way because I'm supposed to graph this for all of these x's forever to the left that are less than negative 2. So again, analyzing the situation there. And then we had a real great discussion. I'm treating you like college students here, trying to make this video and, in a timely fashion. What is that a picture of in the blue? And again, I firmly think there are people in this room that still don't know this. What's that a picture of? It's a quadratic, which makes a picture of a what? Parabola. And then what you should assess is, what is the vertex before you do anything? You got to locate where that vertex is from your knowledge of shifting and all that other stuff. And where is that vertex? 0, 1. But now it's a piecewise function. Am I even allowed to plug in 0 for x? You tell me. Yes or no? Is 0 within that interval? Yes. So guess what? The very first thing you should plug in is 0, 1, and happily write that vertex because it is part of my conditions. And now that you know this is a parabola, you will graph a parabola knowing this is the change where things reflect and have symmetry. In this case, they do have y-axis symmetry for this particular one. And then what's the next number I should plug in? You make it simple. You should plug in negative 2. By the way, am I allowed to plug in negative 2 from the conditions? Yes or no? Yes. And what do I get when I plug in negative 2? Negative 2 squared is 4. 4 plus 1 is 5. Negative 2, 1, 2, 3, 4, 5. From your knowledge, it's a closed dot, by the way, because it says equals. This is a parabola, so make it curved like that. Make it parabolic in that picture. And then, what should I plug in next? Well, actually, 3. But should I plug in 3? Yes. But what should I put at 3, comma? An open circle. I'm getting more people answering it, and those that aren't, I don't know what you're doing. Isn't that 7? No, I was never good at math. 3 squared is 6. 3 squared is 9. Plus 1 is 10. And then 1, 2, 3, 10. People interrupting my class. All right, and I'm going to reflect this over so that I get a little bit more shape. I missed that dot. And then you see a little bit of a parabola there. All right, and that's that piece, and it stops. There's no more to graph of that because it's controlled between negative 2 and 3, not including 3. And then what's this last picture? Boy, I wish I had purple. Oh, well. I guess I'll just do green. What's this last thing a picture of? Not even doing y equal. What's that last picture a picture of? It's an absolute value, which ends up being a picture of a what? A V. Now, where is the vertex of that V? And it's all about the shifting. Which way is this V shifted? It's shifted. I'm pointing to this right here. Right 5. This seems weird that it's here. So let's do this. Plus a negative, and then put minus 2 after it. Left 5 2 down. So by the way, can I plug in 5 for x from the conditions? Yes or no? From these conditions, am I allowed to plug in 5? What in the world just happened there? I'm not even in the right... It just went to a different set of notes. I love this computer. Okay, I'm back. Oh my gosh. So 5 comma, what did we say we ended up getting? 5 comma, oh my gosh, the computer's really having a schizophrenic situation going on here. 5 comma what? What did we say? All right, I'll evaluate it, but you should have already told me. What's 5 minus 5? Too late. What's 5 minus 5? 0. What's half of 0? What's negative 2 minus 0? So when I plug in 5, I get what, class? Third hour is going to kill me. Negative 2. And that is the vertex. This just flipped like 7 pages. Oh my gosh. This is how this computer functions. We're back. 5, 1, 2, 3, 4, 5, comma, negative 2. And that is the vertex. By the way, what can we expect this V to do? Go up or down? Down. And now that I know 5 is good, you know what I'm going to plug in next? 3. You know why? Because that's my condition. I should start at 3 this graph, and then 3 to infinity and graph that. Class or nobody, what's 3 minus 5? That's what a teacher deals with. Students don't answer questions. Back in the 90s, I go, hey, class, what's 3 minus 5? And they go, negative 2, Mr. Samulus. We love you. Not now. Now it's just like, yeah. That's all you get. Looks of hate. You should try this profession. All right? Where are you going? Okay. All right. All right. So anyway, so 3, what's 3 minus 5, class? That's what this started. 3 minus 5 is negative 2, Mr. Samulus. What's the absolute value of negative 2? 2. What's half of 2? 1. Here's the zinger. What's negative 2 minus 1? Negative 3. So, 1, 2, 3, comma, 1, 2, negative 3. Oh, was that supposed to be a closed or an open dot? Closed. And then you know what I'm going to do for giggles? I'm going to plug in 7. Because this is supposed to be a V. That's supposed to be the symmetric partner. 7 minus 5, class. 2. What's the absolute value of 2, class? 2. What's half of 2, class? What's negative 2 minus 1, class? Negative 3. Now, this goes forever that way, and that's a piecewise function. I'm done.